Hi, today we are solving a problem from free response calculus test from year 2017. The first problem is done using a calculator. It is about a particle that is moving along the x-axis. We are given the velocity of the particle. We're given the initial position of the particle. Question 1 is to find the acceleration of this particle. Because it's a calculator section and the question is to find the acceleration at a given time, it's purely numeric problem. So what you will have to do is to use your numeric derivatives. So math 8 for numeric derivative, and you are going to type in ddx of this value at this time. The calculator is going to give you the answer of 6.491816041. What you will have to do is you will have to say that the acceleration at 5.1 equals 6.492. So rounding to 3 decimal places. If you just truncate, if you say 491, the nice AP graders are not gonna take a point away. But that is the better answer. And we are talking about, no units. Okay, there are no units here. For part B, we need to figure out the values of t between 0 and 2, for which the speed of the particle is 1. We need to remember the speed is the absolute value of the velocity. Speed equals absolute value of the velocity. I would be solving this graphically, so I would graph this function, because we're trying to find the absolute value. And you have a couple of options here. You can either graph the absolute value of this function, and then, so I got something like this. Okay, if you graph the absolute value, it's going to look like this. So, and then like so. And then you graph the line y equals 1. The second option, if you did not put the absolute value, if you don't know how to find it on the calculator, then you graph y equals 1 and then y equals -1. Remember, you are asked for the interval from 0 to 2, so you will get there these 2 points. Even though your graph, your line 1 is going to intersect your graph over here, and then another one is going to intersect it over here, you will be asked only for those 2 points, so you don't need to put the other ones. How do we do that? Second calc, and then we do 5 for intersect, first curve, second curve. Second curve, yeah. Where is it? So I got the first point is going to be time equals 0.772. It goes 1829, sorry. And then the second point is going to be, curve is the blue one, second curve is the black one, and my intersection is t equals 1.4005, so 401. Now for part C, we're looking for the position of the particle at time equals 4. And the question is the particle moving towards the origin or away from the origin at that time? To figure out the position, we have to remember that the position is the antiderivative of our function v of t. But we need to figure it out at time t equals 4, and we have to remember about the initial condition. Where was the particle originally when it started moving? It already was at the 7, and then it moved somewhere, and then at 4, it's going to be somewhere else. So what we will have to say is the position of the particle, x of t or s of t, whatever variable you're using, is going to be 7 plus the integral from 0 to 4 of v of t dt. On your AP calculus test, you have to write it down. You cannot just say, oh, my answer is whatever. So you have to write this down. And then the calculator is going to give you 6.712. So that is the position of the particle at time t equals 4. To answer the second part of this part of the question, is the particle moving towards the origin or away from the origin? So at time t equals 4, the position of the particle is positive. At time t equals 4, from the graph, you will see that the velocity is positive. So the position is positive, velocity is positive, which means that the particle is moving away from the origin. Justify your answer. How are you going to justify it? You're going to say that at t equals 4, x of 4 is positive, v of 4 is positive, therefore the particle moves away from the origin. The last part here, during the time interval from 0 to 4, does the particle return to its initial position? And give a reason for your answer. We can see that because our position function is differentiable from 0 to 4, that means it's continuous from 0 to 4. So we know the value of x of 4. So let's think about something that is maybe slightly bigger than 0. So maybe find x of 1. So for part D, I will find x of 1, which is going to be 7 plus integral from 0 to 1 of v of t dt. Same thing, I do it on the calculator, and I get 9.404. Okay, now I can see that at time 1, the particle was at 9.404. At time 4, the particle was at 6.712. So that tells me that by intermediate value theorem, the particle has to go through 7, right? It goes from 9 to 6. So the particle has to go through 7 between times 1 and 4. So by intermediate value theorem, the particle will return to its initial position. And that's our problem 1. In this second problem, lots of words, but let me walk you through this. We are given a time interval. We're given 2 tanks of water. Water flows into tank A at a given rate. At the same time interval, water flows into tank B at some other rate. We don't know what it is. Both tanks are empty at time t equals 0. The graphs of our 2 rates are given to us. So this is our graph, rate A. Okay, it's this one. And then this guy is the B of t, which we don't know. So that rate is the one that we don't know, but we have a graph of it. Question 1, how much water will be in tank A at time t equals 4.5? How much water is going to be there at tank A at time t equals 4.5? That one, because we know A of t, this is the rate. How much water? We have to undo the rate, so we calculate antiderivative. We do it in our calculator, and we will write down for part A that we're looking for the integral from 0 to 4.5 of A of t dt, which is going to give us 66.532 liters. That was a warm-up. Part B. Now, during the time interval between 0 and k hours, so k hours is this value. Okay, this value. It looks like 1, but we'll find out it's not 1. Water flows into tank B at a constant rate. So this one, it might be hard to tell, but this is just a horizontal segment here. Constant rate of 20.5 liters per hour. What is the difference between the amount of water in tank A and the amount of water in tank B at this time t equals k? So at this point, we will be, well, first we need to figure out what this value is, what k is. So I am going to just graph this on my calculator. And this 20.5, I don't know what's happening here, but I can at least draw a line and I can find the intersect. And I can find k. So I'm doing second calc, intersect, one curve, another curve. And k was equal 0.893, I think it's 892. Oh no, 892, that's a 0. 8992. Now I can calculate the difference in the amounts of water. Again, the difference in the amounts of water, that's going to be the antiderivative. So I would have to set up my antiderivative from 0 to this value of k, 0.892. And I'm subtracting, I'm taking my 20.5, that's the constant rate of tank B, and I have to subtract the rate at tank A. I do it on a calculator, and I am going to get 10.599 liters. In part C, we are given that the area of the region bounded by the graphs of A of t and B of t over here between k, this is our value k, and 2.1416, so between those 2 points of intersection, this value is given to us. It's 14.4. The question is how much water is in tank B at this time. So in other words, we're looking for this area over here. Okay, so we're looking for this area. And we know that it's going to consist of this area, which is just a rectangle. So I can say that I'm looking for the area from 0 to 2.416 of b of t dt. That's going to be the area from 0 to k of b of t dt plus integral from 0 to k, from 0 to k, plus integral from k to 2.416 of b of t dt, just adding two integrals. This guy is just the rectangle. So this area from 0 to k b of t dt is going to be 20.5 times k, which we found, and that's going to give us 18.286 on a calculator. Okay, now this area, so integral from k to over here, okay, between those two values. Well, we don't know what the function b is, otherwise it would be easy. But we do know what function a is, so we can find the area under this curve and then subtract this little piece. So that's exactly what I'm going to do. I'm going to say that the integral from k to 2.416 of b of t dt equals integral from k to 2.416 of a of t dt minus the area between those two curves, which is 14,470. 14,470. Okay. Once I do it on the calculator, I'm going to get 30.0278, so 0.28. And my final touch, I will have to add both of those. So I'm going to get well, I'll just add those. So 18.286 plus 30.028, that is 48.314. So my answer is how much water is in tank B. At time 2.416, there are 48.314 liters of water in tank B. That's my part C. The last part says, during the time interval from 2.7 to 4.5, the rate at which water flows into tank B is modeled by this, so on some interval over here. Is the difference W of t minus A of t, is it increasing or decreasing at this time? So we're looking at the increase or decrease of the rate, because the question is the difference increasing or decreasing? That tells us we have to calculate the derivative of the difference. So W prime minus A prime. And when are we calculating it? At time t equals 3.5. So that is our numeric derivative. W prime at 3.5 minus A prime at 3.5. We do it on a calculator. We get negative 1.14297, 1.3. The point is our difference is negative, which means that the difference is going to be decreasing. And that's what we will answer. The difference is decreasing because the difference of derivatives is negative.